So at the Air Force Research Laboratory, we're looking at a lot of different applications for quantum, not just quantum computing, but 6 of our 9 technology directorates have very active research programs in quantum. Just to be brief here, so we're looking at things like timing and sensing using quantum clocks, different types of quantum sensors, to really get at the problem of quantum-assisted PNT, positioning, navigation, and timing.
Today on the Daily Scoop podcast from the Scoop News Group, preparing for the age of quantum. A special panel from FedTalks examining how federal agencies are getting quantum ready. It's Tuesday, October 8th, 2024. Welcome to the Daily Scoop podcast, where you'll hear the latest news and trends facing government leaders. I'm the host of the Daily Scoop podcast, Billy Mitchell. Thanks so much for joining me. Now, let's get to today's top headlines. The National Institute of Standards and Technology's Artificial Intelligence Safety Institute is seeking information on the development of chemical and biology-focused artificial intelligence models. In a Federal Register posting, the AISI said it is specifically interested in potential benchmarks and evaluation tools for understanding these models, as well as guidance on mitigating the kind of security risks they might raise. The focus on these kinds of AI models comes amid growing excitement that they might be used to advance scientific goals, like identifying new medications, but also concern that the technology could create myriad national security risks. By reducing the time and resources required for experimental testing and validation, chem-bio AI models can accelerate progress in areas such as drug discovery, medical countermeasure development, and precision medicine, the posting states. In other news, as the Department of Defense experiments with biometric devices to better track the health and wellness of personnel, it issued a $96 million award last week to Finnish health technology company Aura to put its smart rings and services in the hands of service members. While the department didn't specify in the award announcement how many rings would be purchased under the contract, the retail for the rings runs about $299 to $349. It explains that the contract will also provide a suite of data analytics services that the Pentagon's health arm can use to take action on the biometric information generated by the devices. This isn't the first time the DoD has used Aura rings. The department's Defense Innovation Unit used the device along with Garmin watches during the COVID-19 pandemic for its rapid assessment of threat exposure project, which paired the commercial biometric technology with an artificial intelligence algorithm to detect infectious diseases in advance of symptoms. Likewise, the Air Force last year distributed more than 1,000 Aura devices to graduates of the First Sergeant Academy. And the Navy in 2021 gave out about 300 of the rings to sailors and Marines on board amphibious assault ship Essex to study fatigue. For more news at the intersection of the federal government and technology, visit fedscoop.com. If you missed FedTalks last month, you missed a fantastic panel on how federal agencies are preparing for the age of quantum. Fresh off NIST's release of new post-quantum cryptography standards, panelists discussed what's ahead as they look to secure federal systems and information from attacks powered by quantum computers. During the panel, I was joined at the Andrew Mellon Auditorium on stage by Nick Polk, Branch Director for Federal Cybersecurity in the Executive Office of the President, and Dunkin, CIO of the Department of Energy, and Michael Hayduk, Deputy Director for Quantum in the Information Directorate at the Air Force's Research Laboratory. Let's go now to that interview. This is our first big panel of the day, so we'll see how much we can get through. But this is a really pressing topic. Welcome everybody to the stage. We got a little bit of a tee-up of this conversation when I was speaking to Drew. We talked a little bit about the NIST standards, which really brings this topic to a head. So I'd love to start there. Nick and I actually spoke recently on the Daily Scoop podcast about this after the NIST standards came out, but I'd like to sort of revisit that. And Nick, maybe I'll start with you again, since this is a topic of great interest and focus for you within the Executive Office of the President. But tell us about the significance of those NIST standards and what they really mean in a broad way. That you know, it's really technical, but can you distill it down in a way that, you know, maybe you're talking to your mom or somebody who doesn't really grasp the technical terms?
Yeah, definitely. Thank you, Billy, and thank you all for having us. This is, always really cool to be in the Andrew Mellon Auditorium, and thank you especially for not saying anything as I slipped some of those croissants in my backpack earlier today. But yeah, so this is actually a very exciting time for the migration to post-quantum cryptography. Very quickly, the NIST standards address asymmetric cryptography, which is the most commonly used cryptography across the internet today. And the way it works is very similar. If you have seen the second version of the Parent Trap, where Lindsay Lohan does the like the multi-level handshake with her butler, very similar handshake actually for asymmetric cryptography. I apologize to any cryptographers in the audience. But we've known for a while that that handshake can be disrupted by a quantum computer, and it can be played back in or reversed in a way that would allow somebody with a sufficiently powerful quantum computer to pull the key that's being exchanged out of that handshake and use it to reverse engineer the encryption and make the data that is encrypted into plain text, which is readable by anybody. So the NIST standards successfully address the algorithm known as Shor's algorithm, which we have known about again since the 90s, and they re-encrypt the data in a way that a quantum computer of sufficient power would not actually be able to interrupt that handshake. So it's really exciting, and it's securing big swaths of the internet for the future, and it's a process that NIST has been doing since 2016. Big accomplishment.
Yeah, well, kudos to NIST and everyone involved in getting that across the board. Dr. Hayduk, following that up, anything to add there, but also, more importantly, how are you looking at, now that those standards are out there in the wild, adopting them or moving in a way that, the Air Force or the Department of Defense are really moving in that direction?
Sure. So first off, thank you for the invite today. It's just a huge honor to be here in such a great location and great event. So yeah, just to follow up on that, it's great to now see the standards out. We've been concerned for quite a while on the so-called store now, decrypt later problem that's out there with our adversaries capturing the data, storing it, and then eventually being able to decrypt it when it is still, certainly a valid need. So having the standards out there then allows us certainly to move ahead. It's going to be a process within the Air Force. I work research and development, so it'll be outside our scope of what we do in that lane. But definitely we'll be implementing, those standards, and certainly it's critical for us to do that to protect our systems.
And from a CIO's role, the practitioner really, distilling, absorbing, and moving forward with those standards. What's that look like now for the Department of Energy?
Hey, thanks, Billy. And it's great to be here. Thank you for the invitation. Before I answer that question, I'm going completely rogue on you for 1 second. So last week I was at Billington, and I think 8 or 10 people came up to me and told me that I was leaving in 8 weeks, and so I just wanted to dispel the rumor that I'm leaving in 8 weeks. If I have a job, I don't know about it. So just wanted to put that out there. Okay. I mean, it was a very specific rumor. So moving right along. So for DOE, right, when we look at an IT standpoint, there's a couple things right away, right? One is we've already done an inventory, trying to figure out what we have and what it would cost to move those things, everything to post-quantum encryption, right? We've got the algorithms now to test out, to start using. That inventory results in a huge number in terms of cost, so we're not going to be able to move everything right away. We're looking at what the most important things are. What are our high-value assets that are subject to needing post-quantum encryption? Because some things it may not be an issue, like where we don't store a lot of data. But where do we store that high-value data? Where do we need to move it? And then the other big thing right now is stop the bleeding, right? Don't buy new things that don't implement post-quantum encryption. So let's not put more things into the system. Let's figure out what we need to change, and then we're moving forward on that roadmap to make that change.
So I'm curious, and Nick mentioned Shor's algorithm. We know with certainty that this is something that's very certain to happen in the future, but we don't know exactly when this sort of shift's going to occur. So the time element is sort of where I want to go next. And I'm curious about, one, how long is this journey going to take, and two, what's the level of urgency if we don't know exactly when this shift needs to occur? Obviously, we'd rather it happen sooner rather than later, but I would love to hear from each of you sort of that time element, what the timeline looks like, and when you think this is really going to need to happen. Nick, maybe we can start back with you.
Yeah, definitely. So I'm going to quote my boss, Claire Martirano, for a second and say it is not a destination but a journey. So we are going to be constantly migrate encryption for the next foreseeable future. We've gotten extremely lucky to this point that the mathematical algorithms that underpin current encryption have been extremely resilient to the most powerful supercomputers known today, to the point that in many cases it would actually take more time than there has been in the known universe to decrypt some of these using current computers. So that's very lucky, and really, again, a testament to the hard work of the cryptographers across the US government and the international standards bodies. But now that we are moving towards more powerful supercomputers and eventually quantum computers, we're going to constantly have to ask ourselves, is our encryption secure? And by the way, we should already be doing that because there are some cases where it has not been. But we're going to have to constantly ask ourselves that, and we're going to have to design from default, to borrow some terms from CISA, information systems that we can constantly switch out cryptography when we do realize that it might be becoming vulnerable. And so it's going to be an ongoing process, and one that's going to require a partnership between the cryptographers, the CIOs and CISOs across the US government and the private sector, and something that we always have to be aware of and ensure that we are not becoming complacent once we finish the first step of this migration that Ann was talking about.
Yeah, just to, I guess follow up on that. So I love the idea about, being able to swap out, right, as needed. I think that's going to be absolutely critical going forward. But spinning it from, my perspective in the quantum world here, when will we have a cryptographically relevant quantum computer? Subject of much debate, lots of discussion out there. Is it going to be 5 years, 10 years, 10 plus years, 15 years? Not quite sure. We just know the technology is moving very quickly. Probably quicker than we imagined just a few years ago. So it's imperative that we, start now as soon as possible and take those necessary steps. And the sooner we can get away from store now to crypt later, the better off we're all going to be.
Yeah. To Michael's point, every one of my labs that works in quantum has a different opinion as to how long it's going to be. Some are pretty short, some are pretty long. We know that our journey to get there is a decade or more in terms of all of our systems. It's probably even longer, looking at that long tail. But the ability to start now, to stop creating new situations, and to Nick's point, to make sure that just like we now build software in ways where it's easy to decompose that software, it's easy to replace modules, the same thing needs to happen with encryption. It needs to be much easier to essentially pull a quantum module out of a solution, put a new module in when we have new technology, new algorithms, where we need more capability.
You mentioned those labs, and obviously Air Force Research Lab has its own work ongoing in the quantum space. I'd love to hear about some of the examples that those labs are doing on the R&D side, obviously, which is a little different from putting it into practice. If you can shed light also on how you go about transitioning that eventually from the research side into practice, that'd be great. But more so, would love to just hear any details you can share about some of those ongoing research work that each of your agencies has.
You may start? Okay. Yeah, so and I had to get my notes out because we have at least 5 labs working in quantum. Argonne has their QNext initiative. So they're looking at a wide range of efforts, including how quantum interacts with our work in machine learning, but also really fundamental things like what are you going to make your quantum chips out? What are the materials that are best? What are the best ways to cool it? What are the best ways to scale cooling systems for these solutions? At Lawrence Livermore, they have a quantum design integration test bed, which allows them to develop mission-relevant quantum processors and algorithms. They're also there testing new materials and components for building tomorrow's quantum systems, because one of the things we do at DOE is we make big bets, we make lots of bets. So we'll have multiple labs working in the same space, looking for solutions. Often that means we come up with multiple relevant solutions. Other times it means we come up with, one of them comes with the right solution. A couple others at Oak Ridge, they're developing a quantum roadmap for how to align our quantum facilities across the enterprise to meet DOE's mission needs. And then Berkeley is working on quantum networking. There are many other examples, but I won't take up all the time by sharing all of them. But I'll say that across our enterprise, we're looking broadly at how quantum is going to enable science, because all science is computational now, so that we need quantum to enable the computation we need to move our mission forward.
Yeah, so at the Air Force Research Laboratory, we're looking at a lot of different applications for quantum, not just quantum computing, but 6 of our 9 technology directorates have very active research programs in quantum. Just to be brief here, so we're looking at things like timing and sensing using quantum clocks, different types of quantum sensors, to really get at the problem of quantum-assisted PNT, positioning, navigation, and timing, in the absence of a GPS signal where it's been denied or you've lost that signal. Quantum networking, quantum communication type systems, where we're using this property called entanglement, where we're looking at new types of security, as well as linking together those quantum clocks and quantum sensors and quantum computers. And then finally, on the computing side, we are not building a quantum computer in AFRL, but we're leveraging all the work that industry is doing in that space. We have several partners out there, and we're really developing the workforce to look at, all right, once we have a practical quantum computer, what are the really hard and important problems that we could solve in the Air Force using quantum computers?
We've got a minute left. Each of you, if you could spend 15, 20 seconds going down the line, the biggest thing that folks in the room, whether they're on the government or industry side, could help with in this quantum and post-quantum cryptography space. Let's start with you, Nick, and we'll come back this way.
Yeah, so the biggest thing now is just finding this cryptography wherever it may be, and that is both a manual and an automated process. So we encourage agencies to do both. There are some parts of the network that just aren't reachable by automated solutions, are just weird. They're architected odd, they're air-gapped. It's going to be manual. It's going to require some, good old elbow grease, but automated solutions are also very good for finding out the known unknown. We encourage folks to do both. If you get any trouble for doing both, don't worry, we got you, fam. But that's really the important thing to be doing right now.
So a little spin there. So the Air Force, our perspective is certainly continuing to push on R&D, not only in PQC, but other areas as well that I talked about, and developing the workforce, the right size workforce, can be critical for us moving forward.
Yeah, so I'll take the IT perspective since you've hit the research one. So from an IT perspective, there are 2 things, right? So if you're a CIO, right, you need to take that inventory Nick talked about, and you need to start working towards identifying what's most important to move, getting those things moved to quantum, post-quantum encryption, so that we can ensure that our data is safe and that we eliminate that vector of store now, decrypt later. And then from an industry standpoint, we need you all to bring us solutions that are post-quantum ready. So update your encryption capabilities so that we can buy something from you that's ready now, that we don't have to retrofit later.
Fantastic insights all across the board. Thank you guys so much for the time today. It was a fantastic conversation. Let's give them a round of applause. For more on preparing for the age of quantum, visit fedscoop.com. Thanks so much for tuning in to another episode of the Daily Scoop podcast, available on all podcast platforms. If you've already rated the podcast on your platform of choice, thanks so much. High ratings and good reviews of the show help more people to find it. The Daily Scoop podcast is a production of the Scoop News Group in Washington, D.C. Adam Butler and Carlin Fisher help put the show together, and the entire Scoop News Group team contributes. We'll be back next week with more top headlines. Until then, I'm your host, Billy Mitchell. Thanks so much for listening.